Hello everyone. Today we're going to see microprocessor interfacing and its application subject in that fifth unit applications using 8085 or 8086. In that first topic is stepper motor interfacing with ULN 2003 driver IC. First of all, you need to know what is the use of the driver IC. Generally, any motor can be controlled with processor IC, but directly we cannot control since the signal which is coming out of the processor IC, which is not sufficient, uh, which is not having sufficient magnitude to energize the coil which is available in the motor winding. So we need a intermediator IC which will act as a driver IC or which will which will give us high voltage and high current capacity for driving the coil. That means energizing the coil. Then only the motor will run according to the energization of the coil. So whatever the signal which is coming out from the processor IC, which will decide which coil has to be energized. But it is not sufficient to energize. Microprocessor IC, which will decide which coil has to energize. That signal need to be boosted. For that, we have to use the driver IC. So if you see here, the stepper motor driver circuit are available readily in the form of ICs. Okay, and ULN 2003 is nothing but a driver IC, which will give us what high voltage and high current Darlington transistor array. So what is this Darlington transistor array means? Transistor we know which will act as an amplifier. Okay, so this amplification process is required. The signal which is coming out of the microprocessor needs to be amplified. Then only that amplified signal which will make the coil to energize, so that that particular coil will make the motor to rotate either in forward direction or reverse direction. Consider first this coil is going to energize, then this coil is going to energize, then this one and this one. That means the motor is going to rotate in clockwise. Or else, if you consider the microprocessor is decided to energize this coil first, then this second coil, and then this one third, and then this one. That means the motor is going to rotate in reverse direction. So I hope you all understood what is the use of driver IC, which is connected in between the processor and the. Here you can see 8085, which is connected to 8255. You all aware what is the purpose of 8255, which is acting as a PPI, programmable peripheral interface IC. So any peripheral here, stepper motor is nothing but the peripheral device, external device, which needs to be connected to the microprocessor via this PPI 8255 IC. But whatever the signal which is coming out of 8255, which is coming from 8085, that will reach the motor via 8255, but which is not sufficient, having not sufficient magnitude. So when which coil has to be energized, that signal only will reach the stepper motor coil, but unable to energize that signal. So we will be requiring driver IC called current driver IC. This current driver IC is nothing but that ULN 2003 IC. Now we will see the program related to this. So you can see totally 4 windings are there, A, B, C, D. This how a stepper motor will be energized to get a particular direction, whether forward direction or reverse direction, everything we will see with this. Consider here A coil, and this one is opposite A dash coil, and B and B dash coil. If you try to energize this coil, okay, then automatically A dash coil will be de-energized. If you try to energize B coil, automatically B dash coil will be de-energized. At the time, we are going to energize two coil, either AB or A B dash. If A is energized, automatically A dash is de-energized. If A dash is energized, A will be de-energized. So as per this, consider this is a rotor which will be attracted with the help of this coil. If it is get energized, as per the coil which is energized, the rotor will try to rotate towards that energized coil. It's like if a magnet is placed, the iron piece will try to attract towards that magnet. The same principle here. A dash, consider here A equal to 0. That means I am trying to de-energize. That means A dash will be 1. If A equal to 1, A dash will be 0. Okay, so I am trying to de-energize. Consider I am trying to de-energize A. That means automatically A dash will be energized 1. Okay, and then similarly I am trying to energize B. Okay, say for example, okay, any coil you can energize. At present, now A dash is energized and B is energized. That means B dash is de-energized. Okay, so now the rotor of the stepper motor will try to align between B and A dash, because these two are at present magnetized. So that rotor will be aligned in between B and A dash. If in case you are trying to energize, already energized B is there. Now I would like to energize A. Okay, that's what here in this first diagram already over. Now I'm going to explain the second diagram. Already B is there. Now I'm going to try to energize A instead of A dash, which already A dash is energized in the previous process. Now I am trying to energize A. That means energizing means applying supply to the coil. Okay, so now A dash will be 0. Still my B is still it is in energized condition. That means these two, A and B coil, these two are in energized condition. So the motor will now rotate, rotate and align between A and B. And then in the third diagram, you will be able to see which one they are energizing. Like A will be as it is. Now they are trying to de-energize the B. That means automatically B dash will be energized. A and B dash are energized. That means the rotor which is there in this second position will go to this third position. Okay, in this position. Similarly, if you see here, the rotor, if I energize A dash and B dash, that means apply 0 for A and apply 0 for B. That means automatically A dash will be getting 1 and B dash will be getting 1. That means these two coils are energized, so rotor is got aligned. So if you see this step by step process of the stepper motor working principle, initially this is a position, then it tries to rotate towards the what anti-clockwise direction. So initially A dash B dash, then A dash B, then AB, then A B dash, then B dash A. If in this process, if you energize the coil, the rotor will rotate in anti-clockwise. If in case you would like to rotate, make the rotor to rotate in clockwise, means consider at present it is in this position. The rotor is in position. So B and A dash is in energized condition. Next, what we should do? A dash and B dash should be energized, so that the rotor will come and align in between these two. Then the rotor need to rotate and align here. That means B dash and A. Then A, B. Like that, if you energize the coil, then the movement of the rotor will be in clockwise. Now you can see this is VCC. Here A1, A2, B1, B2, that is coil name that you don't consider at present. VCC plus supply. Everywhere 1111 means every coil is having VCC. Not only VCC is required, also ground is required. So ground 0000. So all 4 coil is available with the supply, but that particular coil need to be energized. Okay, supply is readily available, but to which coil the supply has to reach, that will be decided by this A2 and B1. You just consider this A2 and B1 as just AB. Okay, don't get confused with A2 and B1, just consider AB. Okay, so here A will be 0. That means what? A dash will be 1. A dash will be 1. Then B will be 1. Okay, B will be 1. So A dash is 1, B will be 1. Your rotor is aligned here. So this process which makes the rotor to align here. Okay, then what is the second step? The rotor should align between A and B. So A and B should be 1. A dash and B dash should be 0, 0. So look here, A is 1 and B will be 1. Okay, so that it is aligned in between these two. Then the next one, A will be 1, B is 0. That means B dash is getting supply. So B is 0. So A will be 1, B will be 0. So look here, A will be 1. That's why it is aligned here. And B dash is energized. That means B is 0. Okay. Now at present, I need to mention this with this value. Every row value should be converted as a 8-bit value. So here only 4-bit value is there. You just add 4 zeros along with this. So this one 1010, nothing but A. Along with this, you write 4 zeros, nothing but A0. I have to give 8-bit data to the processor. At present here 4-bit data is available. So 8-bit data should be given. That is why I am including in the right side 4 zeros here. Just add 4 zeros. This portion is A and this portion is 0. A0. Then the next one 1110. 1110 is nothing but E0. 1100, nothing but C0. 1000 is nothing but 80. Okay. 1000, along with that you have to include 40. Here also 40. Okay. So if you reverse this, here A0, E0, C0, 80, which makes the rotor to rotate in anti-clockwise. If I reverse this, instead of A0, if I give 80, C0, E0, A0, if I reverse this like this, then the motor will rotate in clockwise. This direction will make the rotor to rotate in anti-clockwise. Okay. Now we will see the program. In that program, we will use these four values: A0, E0, C0, AT. So processor 8255, stepper motor controller, then stepper motor. Okay. So here this control word register is there in 8255. That control word register, here we are not getting any input to the processor. So all the port, if it is working as output port, that is sufficient. So 80, this one is control word register address. Already you all aware FF26 is a control word register address where you can initialize the port, whether it has to work as input port or output port in 8255. Okay, 80 will make all the port to work as output port. That controller register format you have like this. Okay, 80 if you put in controller register, you'll be able to understand which port is going to work as input and which port is going to work as output port. Since 80, which will make all the port as output port, because why it has to make everything as output port means from 8086 the data is sent only in one direction. We are not getting any data from stepper motor to the 8086. So you don't need to have any input port. 80, then that will be transferred to DX. DX is nothing but FF26. FF26 is control word register. Then this address is port A address. Through port A, we're going to send that which coil need to be energized. FF20. So FF20 is a port A address where I'm going to send initially A0. Already I have explained what is A0, what is E0, what is C0, what is 80. Everything I have explained. Which coil need to be energized so that the rotor will align accordingly. So A0 meaning already you are aware. So A0 will be sent to DX. DX is nothing but FF20. So call 1100. Why call 1100? Na? This is a stepper motor. So in stepper motor, which will take 1 second. Consider the stepper motor is you are using in your digital your analog clock exactly at 12 o'clock. Okay, the needle will not move like what a continuous rotation like a DC motor. The needle, how it will move, consider it is in 12. It will take one step, then it will take another step like this. Like this, one step, then next step, then next step, like this, one by one it will take. It will not run like a normal motor. It's a stepper motor, step by step movement only it will take. So consider at present it is in 12 position, in clock position. The next step will be 12:01. Okay, so for this the angle between 12 and 12, that next point in analog wall clock, if you see, you will be able to have an angle between the first position and the next position. Nothing but this angle position is 1.8 degree. Okay, so 1.8 degree. 1.8 degree na, from this to the next step, this angle is 1.8 degree, the motor movement. So every step it will take 1.8 degree to reach the starting position. Like this, it will take next step, then it will take next step, like this it will take. So to reach the initial position, it has to take how many steps? Is nothing but 1.8 is one step angle, 1.8 degree angle into 200 steps. Like this, it has to move 200 steps to reach its initial position. That means to reach 360 degree, okay, it has to take 200 steps, since each step is 1.8 degree. Okay, so why I'm explaining all those things is that call 1100 na, it is given which coil has to energize. Okay, immediately I cannot make the next coil to energize, because that coil has to energize. It will take some time and will make the 1.8 degree movement will take some time, because it is a step, it's not a continuous rotation. So that electrical signal has to be converted as a mechanical movement, so it will take some time. Up to that, the microprocessor should not send any other data, so the microprocessor has to go for a delay program. Simply it will load some value and it will wait, it will wait for the motor to take 1.8 degree. Okay, so after sending A0, it will go call 1100. Call 1100 na delay program. Load some value in BX register and then move AL with FF. No operation, no operation, no operation, no operation. That means you are what? Waiting. So simply you are executing a no operation line and then decrement AL. Decrement AL means what is AL? FF. Okay. So FF should be get decremented as FE, FD, like that. It has to become 0, 0. Okay. So once if it becomes 0, 0, up to that it will up to that it will jump no 0, it will go to no operation. Again it will decrement FEFD, like that. Once this FF will become 0, 0, it will check this jump no 0 1003. That means sorry, this is 1005 decrement AL, it will go here, then it will check whether this is 0 or not, then again it will go 1003, it will load that value. Okay, so until this BX and AL become 0, it will be keep on decrementing that value. Okay, after that it will return. Return means where you have called, to the next line it will come. Here only we have called, so it will come to the next line. In this line E0, the next coil will be energized. Then once if it is energized, it has to take another angle, so another mechanical movement, so it has to go for a delay. So already I've explained what is A0, then E0, C0, 80. That's it. Again jump 1006 na, this operation should follow again and again. Only just it will rotate from 0 degree to 360 degree, then it will stop. It's not like that. It will be keep on rotating, like a 24 hours clock, it will be keep on rotating, no? So like that the motor will rotate, stepper motor. Okay, I hope you all have understood stepper motor working principle with detailed program explanation. Thank you.